Hello, Gut Check Project fans and KBMD Health family. It's now time for episode number 72. I am your host, Eric Rieger, joined by the awesome man himself, Dr. Kenneth Brown. What's up, Ken?
It's going great. We are episode 72. This is awesome.
It is awesome.
And today we're going to be talking about poop swapping, if you're into that.
So we're basically talking about other people's shit.
We're going to talk about other people's shit, yeah. In fact, it's so exciting that what we're going to do is talk about a study where possibly everybody's trying to be younger, possibly the fountain of youth actually is in poop. And so poop is being looked at for a lot of things. And I'm actually looking at it also because if you heard that voiceover that is now introducing our shows, we're spending a lot of money on a professional voiceover there that I'm going to have to start selling my poop for fecal microbial transplants. We probably shouldn't have gone with such a high budget voiceover person.
The more important thing is, I think, is do you have the characteristics that someone would want to use your poop?
That is a great question. We're going to talk about that because what we're going to do is cover a study that came out that a lot of my patients are asking me about, and it's been getting a lot of press, and rightly so. Basically, they gave old mice, young poop, spoiler alert, some cool things happen, and that's what we're going to talk about. So fecal microbial transplants. You know, we did talk a little bit about this with Dr. Sabine Hazen.
We did.
Episode 58, she wrote the book, Let's Talk Shit.
She did.
And we did get into that. And so she is a pioneer in this field, and she's really trying to push the boundaries on fecal microbial transplant. And that's what we're going to talk about today. Swap and poop.
Swap and poop. But I mean, I think the results themselves are, it sounds crazy because it's just not something that we've ever done before, or not that we've talked about in modern medicine, I guess you should say. We'll get to that in a moment.
It's a super hot topic. So we had the my GIA gastrointestinal meeting, and there was like 3 lectures on fecal microbial transplant. And it seems like whenever I turn something on, somebody's talking about it, and it always gets clicks in the news. So the news loves discussing it. So it's one of those things that there appears to be some promise, much like our mate episodes, where just look how good it is for you. Oh, but wait, it can kill you. This is going to be a little similar to that. So it's not just, don't just run out and find some young person and say, I need your poop, because that will get you arrested for starters. So don't do that.
Yeah. But it might. I mean, if you're doing it the wrong way, you may get pink eye.
Yeah. But it's after we get done with this, you're going to go, you know what? It's not that bad. Those guys were joking about it, but that is something I'm kind of eyeing. You're going to start looking around for your younger relatives going, you look like you've got great stool.
That is no way to handle an approach to any of your younger relatives, is talking to them about their stool.
What if it just becomes the norm? What if this is, because once you hear about this might actually change your mind.
Well, yeah, that. And I think if I know where you're going, I think that you'll be able to tell from the health habits of the person if that's someone whose poop is worth swapping with.
Yes, actually, yes. So this is such a hot topic that as I was like preparing for this and researching the article that came out, that was a very well done article, an abstract was sent to me, and the article itself is not out yet, but it's going to be published in Circulation Research. And specifically, remember that when your microbiome gets old, you get old. And these researchers, which I did reach out to them to see if they would give me an advanced copy, but these researchers, what they did is they said, well, if your microbiome gets old, you get old, your brain gets old. Well, how does that play into it? And so they're calling it the microbiota gut-brain axis. We talk about the gut-brain connection all the time, but now they're saying, no, it's the microbiota through the gut to the brain connection. And they were looking at how dysbiosis, or a disruption of your normal microbiome being all the bacteria in your body called microbiota, and the genome in that is your microbiome.
Okay.
So when you have a disruption of the normal microbiome that you have, and you have a narrowed amount of bacteria, that can happen just from aging alone. Well, then that actually, these researchers are showing that can actually predispose you to develop all the stuff that we talked about, diabetes, high blood pressure, obesity, but also the risk of stroke. And then if you have a narrow microbial diversity or dysbiosis, when you have a stroke, your chance of recovering is markedly worse. So it all comes down to that. So this article isn't out yet, but it's going to be super robust, because they said that in this article, we go into great detail about the microbiome gut-brain axis. And just that alone says, okay, well, how do I keep my microbiome from getting old. So just start with that, because now we're talking about diabetes, high blood pressure, the stuff that kills Americans, and stroke. That's a huge one. So
wow. So it seems like, as we've talked about early on, and now that we're moving into another episode talking about FMTs, or fecal microbial transplants, that effectively that the diversity and the ability of your body to sustain diversity in the gut is always going to be important, regardless if you're young or old.
100%. We now realize that the microbiome, your microbiome, is an organ. Your brain is an organ. Your heart is an organ. Your liver is an organ. Your microbiome should be considered as an organ.
Would it be fair to consider, going through this, that the sooner that someone in life adopts eating the correct foods, setting up for microbiome diversity, would allow them to more readily adapt to maintaining that, versus someone, although it's never too late to eat healthy or make healthy decisions, but maybe it's just easier if you have children to get them in the habit of eating polyphenols and the correct foods, because you're basically setting up them for a better life of microbiome diversity and understanding how they can help those things flourish. What do you think?
100%. And there's some researchers out of Israel actually showed that in the prenatal period, if the mother's microbiome has dysbiosis, meaning that she has taken a lot of antibiotics, meaning that possibly she eats a very packaged food diet, like highly refined things, and she has a narrow microbiome, that's the microbiome that her infant initially gets exposed to. And then they're showing studies that that infant in the prenatal period has to undo that before it can develop the right one. And those microbiome will competitively try and protect that environment. And if the mother continues to raise the child in an environment where that happens, higher likelihood of that baby having these metabolic problems, fighting obesity for the rest of its life, doing all this other stuff. So you're 100% right that if you have a good microbial diversity, you need to maintain that good microbial diversity by feeding it what it wants. I was talking about this with Lucas last night. I was telling him that we're going to talk about poop transplants, and we were discussing this exact same thing, that as you go through life, there's so many things that can affect your body adversely. Lack of sleep, lack of exercise, poor diet. But as it turns out, your microbiome has a circadian rhythm also.
Right.
Your microbiome sends signals back and forth. It is constantly communicating. So Lucas was saying, hey, remember when everybody used to wear those WWJD bracelets?
Yeah.
What would Jesus do? He goes, when you go to Croatia and talk to Baby Bathwater, you and Eric should hand out those bracelets, but it should say WWYMT. What would your microbiome think? So before you start shoving a bunch of stuff into your system, whatever it is, what would your microbiome think? Because your microbiome is there to help you, but if you don't treat it well, it becomes a parasite that can potentially harm you from the inside out.
It makes sense. I mean, like if your stomach is upset, or if your gut is poor, or if you've had diarrhea, all throughout a particular day, I mean, it wrecks shop. Right? I mean, you feel terrible. Sometimes you kind of feel hot and you feel heavy, and it's a warning signal that things aren't right. And I think that's a normal mechanism for you not to be comfortable when those kinds of things are happening. Absolutely.
And to show just how important it is, let's jump into this study that's getting all this buzz.
Okay.
So the title of the study is, it just came out last month, and it's the Fecal Microbiota Transfer Between Young and Aged Mice Reverses Hallmarks of the Aging Gut and Brain. And this was published in the journal Microbiome. Very well done article. It goes into tons of detail, so I'll try and just hone it down to as best as possible. What this article is looking at is they're looking at transplanting the fecal microbiome from young mice to older mice and seeing what happens in the hallmark specific of aging in the brain, the gut, and the eyes. Spoiler alert, it looks like you can make an old brain young, old eyes young, and an old gut young.
Those are interesting markers, brain, gut, and eyes, because if you think of, the only one that I'm thinking of that they probably left off here that would be another key, like aged marker, would be hearing.
Oh, yeah.
But I like the three parameters they decided to choose. That makes a lot of sense. I mean, with us taking care of an older population frequently, I mean, dementia, poor vision, and incredible disruption in GI health.
Do you think that they tried to do the hearing test with these mice, except when they did the audiology screen and they're in the booth and they're like, raise your right paw if you hear it in this ear. Tell me when you can hear the tone. And then maybe the mice just had trouble, doing that. So hearing loss may have been a little more difficult to figure out instead of just lopping their heads off and looking at the brain, which is what they actually did.
Oh, I'm sorry. Did you say something? Oh, those are two really crappy jokes.
I was just trying to figure out, you're right, hearing would be good, but how would you test hearing in a mouse to know that it actually had subtle hearing loss? I don't know.
Just scream at it, see if it moves.
And that's why you and I are not actually running a bench lab with mice. All right, so spoiler alert, they found some really cool things where transplanting the microbiome into older mice showed some decreased aging signs, but they did the opposite. And they were able to rapidly age the brain, the eyes, in the gut in a younger mice by doing the opposite, taking old poop, putting it in a younger mouse. And this was all published, and what they did is they considered the young mice 3 months old, they considered old mice 18, and really old mice, the aged mice that they talked about, at 24 months. So they had these three separate groups, and they were just looking at that. They initially took all these mice, they checked their microbiome, and then they had baseline for controls on the inflammatory markers of the old and the young. And that way they had controls. They knew that the old mice typically had this much cytokine production, this much whatever. They did intelligence tests on them. They did all this other stuff. So then they analyzed the stool, and they showed that the young mice traditionally had a much more diverse microbiome.
Okay.
So the diverse microbiome in the young mice, and in the old mice, they had dysbiosis, just like what we were talking about. So the question is, if they looked at the actual organs, what would actually happen? So the first organ is the brain. What they did, as I mentioned, that prior evidence has already shown that aged mice have increased inflammation in the brain due to a cell called the microglial cell. And they have higher densities of this. This is the soldier, the immune system in the brain. The microglial cell goes around and tries to defend itself, but then when it gets kind of old, it doesn't do a very good job and actually just gets angry and grumpy and just starts sending off these cytokines. So what they did is they wanted to look at these activated microglial cells, which is the hallmark of inflammation, which we now realize is probably the cause of dementia and those tau bodies and things like that. So they figured that if they can change that, then let's see what will happen to the brain itself when they look at the tissues and the markers. And what they did find is that when they took these mice with baseline higher microglial levels, higher inflammation, they gave them stool from the young mouse, the microglial levels decreased, the neuroinflammation completely decreased to the levels of the young mice.
That's incredible.
That's the key there. It isn't that it went from 24 months to 18 months. It went from 24 months to the 2-month level.
Yeah. It's almost like and I'm not kidding, it's like a time travel to
100%.
whomever it is you're doing the exchange with.
Yeah. And then on the flip side, they did the same thing to the young mice. And guess what? A 2-month-old young mouse, after getting a fecal microbial transplant, had a brain of a 2-year-old mouse, which in our world is, a teenager versus a senescent person.
I do have a question, though. So I can understand, I think that we can all grasp as we think about increasing biodiversity in the microbiota of these older mice by taking a younger mouse's poop and putting it in there, that you are literally changing the makeup. Why do you think it is that taking an older mouse's poop for an FMT would then just suddenly replace the output of the younger person's or the younger mice gut without being balanced out a little bit by what was inside?
That is an absolutely great question. I left a really key part. When they initially took out the stool, or they analyzed the stool, they gave all the mice antibiotics. They made them sterile.
Oh, they sterilized the gut.
They disrupted the gut completely.
Yeah, that answers a lot.
Yeah, I totally forgot about that. Yeah, but that was one of the steps that they wanted to do. So now you have a clean slate. So what they give, they're going to get all of. All right. And you're totally right that your own microbiome should be able to prevent another microbiome from just landing in there completely, which we'll get into with humans here in a little bit. One of the other things is that we're always talking about these diseases, dementia and Alzheimer's and Parkinson's. But the other thing is to keep in mind is that cognitive decline is probably a result of this also. So even if you're not labeled as something, being not as sharp could be because your microbiome is aging and it's not keeping you as sharp. Something to think about. So bottom line is, old brain became young brain became old, so we know that there's a 1-to-1 correlation. So then what they want to do is look at the other organ, not the ear, the other organ, which is a direct extension of the brain. And so Huberman describes the eyes as actually being part of the brain, just outside of the cranial structure of it, because it is essentially so innervated as well. But it's maybe one of the reasons why, as we age, vision becomes such a big thing with retinal macular degeneration and things like that. So what they showed is in the baseline, they know that as you age, complement levels increase in the eye. Complement is an inflammatory marker, and other markers known in the eye as RPE. What they showed is that typically as we age, the more complement, more RPE you have, the more retinal degeneration you have, the more you have troubles with seeing. And so what they wanted to see is, can we do the same thing in the eye? And as it turns out, almost the exact same thing happened. They showed a striking way that if you transferred young donor microbiota into age mice, that you had this improvement in the cytokines, or this improvement in the complement and in this RPE. And it was really interesting because when they looked at the cytokine levels in the aged mice compared to the young ones, what they did show that there was multiple pro-inflammatory aspects going on. And that actually affects the photoreceptors significantly because they're very sensitive to that kind of thing. And so it's not just the complement, but then when they start looking at it's the inflammation in the eye as a result of the microbiota, the microbiome. Brain and eye both deteriorated or got better. So you have somebody that can't see very well, and they gave them young poop, and all of a sudden they're whipping their glasses off, and they're...
I mean, isn't the action, though, of the restorative outcome just alarming in and of itself?
Well, and if you go, that's impossible. You can't rebuild. We're not talking about rebuilding tissue. What we're saying is that the inflammation is creating the disruption in the organ's ability to function.
Exactly. It's not even as dire as thinking that your tissue per se is dead in your eye. Your nerves are so overworked by inflammation, they simply aren't passing on the information to your brain to receive and translate what they're seeing.
That's exactly it. So according to this, and in a mouse model, and according to this mouse model, when you block that inflammatory process in the end organ, it markedly improved. And so there was final one, which is no stranger to us, is the gut.
Sure.
And so they want to say, okay, well, we have this gut issue. We know that as we age, the gut also will have inflammation. And ultimately, the thing that gets talked about all the time is leaky gut. And what they showed is that if you have dysbiosis of the microbiome, then you can have upwards of 30% permeability in the gut, call it leaky gut. And that 30% of the permeability allows lipopolysaccharides, the lining of bacteria, to seep in. I remember Kieran Krishnan from, he was on our podcast.
Right.
I heard him on Dave Asprey's podcast discussing how they've got evidence to show that lipopolysaccharides are the root cause of cognitive decline. And they were showing that it creates this. Now, this is just another example of that when you have dysbiosis and your gut leaks, we've talked about it a million times about how that actually can lead to autoimmune diseases and things like that. But now what we're talking about is dysbiosis can actually lead to lipopolysaccharides getting in, which leads to the inflammatory cascade.
Right.
So looking at this, they were trying to describe it as 3 different organs, when really I'm thinking this is the mother organ allowing the attack on the brain and on the eye. Regardless, when they took the old mice that had lots of lipopolysaccharides floating around and inflammatory markers, interleukin-6, TNF-alpha, all the ones that we always talk about, and they gave a fecal microbial transplant from the young mouse, it essentially went back to normal.
That's so wild.
It's nuts. And then, true to the whole thing, they gave the old mouse fecal microbial transplant to the young mouse, and those mice started exhibiting almost immediately intestinal permeability, inflammatory cytokines, and so that's what's this whole analysis of this is that the young donors helped the older sick mice as a complete takeout. So it's making a ton of news, and rightly so, because it's like, wait a minute, is that truly the fountain of youth? Is the fountain of youth poop?
Yeah, it's interesting, but it's also it begs to question: does this mean that everyone who's aged or older needs to have a fecal microbial transplant? And I would say the answer is probably no, but you could correct me. But the idea is that let's say that someone gets older and they have a lot of these different problems similar to the mice. It's possible that taking a younger, healthy person's poop as a donor and then doing that transplant could possibly reverse some of these issues. However, wouldn't the person who always ate a healthy variety of foods, got the appropriate rest, continued their exercise program and regimen throughout their life, would really not necessarily deviate as far as someone who didn't adhere to it and would have really just worse problems and be a bigger candidate for an FMT versus someone who took care of themselves?
1,000%. And so if you look at the...
That's 10 times 1, just so you know. He always says 100%. That was a 10. So 1,000.
So if you look at the data on this, there's studies that have looked at the microbial composition of animals and humans as we age, and across the board, the microbial composition decreases, becomes more narrow, consistent with dysbiosis.
Okay.
Except in one group, those that are super centenarians, the ones that make it above 90. When they look at those people that live to 100, they've got a microbial content which is very similar to a teenager. They've got high levels of very healthy bacteria, Akkermansia and things like that. So the key here is that, and we're going to get into why it's more of an I was going to call it op-ed, but really it's just kind of my opinion on how easy it is to do on animals and how difficult it is to do on humans. But just like you're saying, so when people are reading about this and they're looking, I looked, and if you look at active studies, go to clinicaltrials.gov, there's 242 active studies looking at all different kinds of issues. Type 1 diabetes, rheumatoid arthritis, you name it. In fact, obesity, there's trials going on right now where they're taking skinny people poop, putting it in big people, and seeing what happens.
Are they doing it with diabetics too?
They are doing it with diabetics, multiple studies with diabetics. Yeah. I mean, there's literally 242 ongoing clinical trials
Don't
trying
get
to
me wrong.
figure this out.
I think the advent of FMT being a rescue mechanism really is fascinating and awesome that we could find it, because technically it's natural and it's accessible and we can understand why it works. But I mean, nobody really wants to wake up someday and say, you're going to have to eat some shit to get better. And knowing that, though, just hopefully would get people to adhere to polyphenols and different things like that that would help boost their natural microbiome.
Their natural microbiota, leading to the microbiome. The genes within your genes. We have 120 genes or something like that, and they've got 10 times that amount. And so those genes are working with us. Yeah. That's a thing that you have to realize. It's like an organ. But we're not the first people to think about it.
No.
So as it turns out, when we look all the way back, everybody always quotes him. Hippocrates, as early as 400 BC, said that death is in the bowels, and also poor digestion is the origin of all evil. This is before he was like, what they didn't, I saw a painting of this. He was actually drinking a Coke, which I thought was like so... I mean,
Coke
come
was
on.
very, very popular back then.
Oh, 400 BC? Yeah. And a lot, I mean, so that was the beginning of it. So at least he was saying that the
400 BC?
Uh-huh.
Which one? Gehong Wu was 1700 years ago, if that matters. So it was a little after.
Why don't you tell us about Gehong Wu?
Who? I think he was the man of yellow soup, is what he called it.
It was right? Yellow soup.
So he was a Chinese guy and
doctor.
Sorry,
yeah.
He was a Chinese Harvard trained medical doctor, And
1,700 years ago.
1,700 years ago. And but he came up with yellow soup, and I think that it basically was an FMT, right?
Well, what is yellow soup? Yeah.
I mean, it was shit water.
It was, when you read about this in the history books, it's really funny. He treated many people successfully who had food poisoning or diarrhea with human fecal suspension that he called yellow soup.
Yeah. But, yeah. Yellow soup is funny, though, because it reminds me of, you've seen Dumb and Dumber.
Yes.
When they sit down at the diner, he's like, what's the soup du jour? And she's like, it's the soup of the day. That sounds good. I'll have that. I can only imagine that's exactly how he handled anybody who had to come in for yellow soup.
Yeah, for yellow soup. So he was able to pass it off in yellow soup. But fortunately, the transfer of fecal matter was done differently here in the U.S. And compared to the Chinese practitioners, we modified it a little bit. So in 1958, the chief of surgery at Denver General Hospital, Dr. Ben Eisman, and his colleagues shared their experience when they productively used fecal enemas.
Okay. What's that, man?
I know. I'm trying to think if it was Dr. Eisman that came up with the idea. It was like, drink this yellow soup. Maybe somebody else went, I got a better idea.
Yeah, let's just go straight
to the source. And so he treated 4 patients that had C. diff colitis, and then thinking at it from another angle, when they were writing about it, what they were describing, C. diff colitis. Sorry, can you explain what C. diff colitis is real quick?
Oh, C. diff colitis is, I'm going to screw up what the C stands for, but difficile I know is the second. Clostridium, yeah. Clostridium difficile. It's whenever it becomes overgrown in the gut, and it seems to be somewhat resilient whenever someone's on high, powerful antibiotics, and when it is the only bacteria that is left in the gut, it just proliferates, and it causes massive irritation, usually bloody discharge and dehydration, and it can be incredibly dangerous.
It's incredibly dangerous. And so what they were saying here, by doing the fecal transplant, we're trying to re-educate the microbiome in there to not allow one type of bacteria to colonize.
Yeah.
Because that is the most extreme version of dysbiosis, one bacteria overrunning your whole system.
Yeah.
And so you need to have some balance, re-education. So that is the history of it. And then when we had Kieran on, he brought up a really cool story, and I got to thinking about this, and I went, oh my gosh, this is exactly it. These guys wrote about it in this article where it said, well, a fecal microbial transplant doesn't necessarily have to be interspecies. It can be between other species.
Oh, yeah.
And Kieran told the story of the World War II when soldiers in the Africa Corps, they would get dysentery, and they were told by the locals to just reach down and start eating camel poop. Do you remember that?
Vaguely. Yeah, I probably blocked that part out. But yeah, no, I do. I do remember him bringing that up.
And so by eating the camel poop, it expedited the recovery from dysentery. So it actually saved many, many lives where they would have otherwise died of dysentery by eating the camel poop. Now, Kieran's explanation, which makes a little bit more sense, instead of the fecal microbial transplant from a camel, it's that where the camel poop in the soil, you're getting soil-based spore biotics as well.
Right.
So it's more than just eating camel poop. You're actually getting the specific probiotics which have been shown to colonize and help, the spore biotics. We did that. What episode was that when we discussed Mega Trio and
yeah, we've
Ultron too?
Yeah, man. It's not that long ago. I can't remember the exact number, but it's only 2 episodes ago we did a revisit publication of Kieran.
Oh, that's right.
So probably 3 or 4 episodes back, or maybe 5. It's probably like 67 or 68. But somewhere in there would be both of those. It's kind of interesting about interspecies consumption of poop, though, too. Both of my kids, I've been fortunate as a dad that they've been really, really healthy. I'll never forget one of my first times after Gage, he's my firstborn, was crawling as a young one. He'd just learned to crawl, getting around the house. Dad's at home by himself watching the kid. I knew I was not qualified to do that. And I was just cleaning up around the house. And at the time we had an indoor cat, and there was a litter box.
Oh no.
Yeah.
No.
I found Gage. He's very happy. He's a very happy young man with a little bit of white rocks and a cat turd in his hand. And I just got rid of it and didn't tell anybody about it until years later.
Like right now.
Yeah.
I was listening to a podcast with Rhonda Patrick and an Israeli scientist, and they specifically said that we should be letting our kids eat dirt.
Yeah.
Specific.
You want another funny story? This one's on me.
Yeah.
Okay. So, growing up, I had a friend of mine named Craig Stobaugh, and they had a dairy farm. And it was an old dairy farm that we worked in. And one of the last things we had to do before the last few cows left the bay where they're locked in, they're eating grain. We got them hooked up to the milk pumps. Well, it was mine and Craig's job to shovel all of the old liquid shit that the cows would leave on the concrete floor out and spray it. Well, it was my job this particular day to have the scoop. And so I'm just cleaning. We've only got like 2 or 3 cows to go. And his dad releases one and then goes back over where the agitator is. I know I'm throwing out a bunch of terms here, but Tim leaves. And then this cow goes walking out, and I'm talking to my friend, I thought, Craig at the time. As this cow's making his way out, I guess there was a big old pile of wet cow shit at the door, and there must have been like an air pocket in it or something. But the cow steps in it, and a piece just goes, ha! Right to the back of my throat. And I'm like sitting there, I'm like, and my buddy Craig saw the whole thing, goes over, undoes the hose because here's the floor and the spigot was only this far off of the floor. He undoes the hose and runs out. And then he comes back in and finds me, and I'm trying to stick my mouth underneath the little spigot right there to just get enough liquid in my mouth to clear it out. But look, I lived this long. That's probably what did it.
I'm sure that's what it is. And yeah.
Cow poop tastes like old grass.
In case everybody's been curious, if you're around a lot of cows, you don't have to.
There's bonus material. So I've done an FMT.
Take Eric's word for it.
I've done an Inter-species FMT.
You know what? And your buddy did a great job. He's like, why wash it out right away? You got to let it colonize a little.
Yeah. He's like, I'm helping you.
I'm helping you. Fortunately, that style of doing the FMT is not needs to be elevated a little bit. In 2017, a randomized trial treating C. diff using frozen oral capsules.
Oh, it sounds so much better.
So much better.
That would have been so much better.
It would have been so much easier. But fortunately, they showed that the microbial transplant doing it that way had like a 96.2% efficacy. So you're taking a poop pill, not launching poop from air pocket cow pies.
Yeah, mine wasn't prepped so much.
And if you look at the meta-analysis, all the data looking at this, most of the data for FMT is all on C. diff. And it really outperforms all the pharmaceutical options, vancomycin, Deficit, things like that. So, yay, it's fantastic. So why isn't everybody doing this all the time? Well, this is where it gets a little bit tricky because in those 242 articles where they're looking at different benefits, it's not ubiquitously across the board. In fact, Dr. Swaroop at UT Southwestern was doing a big trial on FMT looking at ulcerative colitis. Mm-hmm. He actually stopped the trial because he was seeing no efficacy with it. And so that's one of them. But the real reason is in 2019, one person died from it and another person got deathly ill. As it turns out, they were both immunocompromised and they both got the FMT from the same donor, which is interesting. And they were able to culture out a pathogenic E. coli species. And so that one probably was less that the FMT was causing it, more that the way to screen for it wasn't done.
You know, but I'm hoping that doesn't kill the momentum behind it. And it really shouldn't, because, and I'll throw this out there, there's no one watching that would think anything of someone saying that they have become a recipient of blood if they had lost enough blood. But there were a lot of people, probably several thousand, not documented, that suffered from receiving the wrong kinds of blood or bloodborne pathogens. Or later on we've learned there are different diseases or things like that that we need to screen for that shouldn't be handed off to somebody else. So we've improved how to administer blood from donors. This could be really just the same thing. We just need to learn what we need to do to improve it.
100%. I'm going back to better math now. No longer 1,000%.
I like 1,000. I like doing 10 more than what? Yes.
100%, because now there's with the FDA is trying to set up protocols about how do you properly screen, how do you do this so that you don't end up with something like that. And I remember, I think I told you the story when we had a fellow applying for a job with us. He was actually doing some of the research at Yale where they were doing the skinny mouse to fat mouse and showing that the fat mouse lost weight. Yeah. While he was telling us, the waitress was there and she was super intrigued. She's like, what are you talking about? I mean, this is years ago.
I know
I'm talking so many years ago that it was so novel that it was the coolest thing. And he goes, yeah, that's what, like the first mouse models. She's like, oh, and he goes, that may be one of the reasons why homes are obese. Not that they're eating bad, but possibly they're sharing the same microbiome. So then she's like, so do you mean that if I'm like living with somebody that I could potentially like share their microbiome? And he said, more than likely that's true. And right then there was like a 6'4", sopping wet, 120-pound busboy. And she goes, that man just became the sexiest man in this restaurant.
I'm sure he did.
It was kind of funny. So now, anecdotally, here's some experience that I have seen. So I've had multiple patients try this. And I did a podcast with somebody in Sweden who actually had moderate irritable bowel syndrome. Her doctor convinced her to do a fecal microbial transplant, and she went through the whole process with me. Mm-hmm. After getting it, she did not feel good, got worse, and then her symptoms became markedly worse. He said, no problem, let's do another one on you. Did another one, got worse, and then he said, well, I'm giving you from a super donor. So he said he had a super donor and did it a third time. And after that, the wheels fell off. She developed autoimmune disease, Ehlers-Danlos syndrome, POTS, ended up with alopecia, like a lot of really bad chronic health issues. Where before it was just a nuisance, irritable bowel. Now she's dealing with a lot of really, really heavy stuff.
That's terrible.
All because of this microbial transplant. So that's anecdotally one. I have another one where I've had several patients donate to a sibling if the sibling has inflammatory bowel disease. One of them, it really worked well for the inflammatory bowel disease. And something that wasn't discussed in the different trials is that the parents realized if they were going to do it, it would have to be succession. So they did multiple times, like once every couple weeks, multiple times. And it worked. But the siblings would tend to have characteristics of the other sibling. So if there was a propensity for acne in one but not the other one would get the acne. If there was a propensity for weight gain, the other one would get the weight gain. So it was able to help with the colitis, but also some other issues like that. Stuff to think about. These are all just, things. Yeah. And these kind of characteristics, I don't even know, maybe a proper diet after an FMT to cultivate the growth. We don't, all kinds of questions. But if you can end up having a pill, frozen poop, the dementia pill with poop and do that, that may be a much better alternative than saying, well, the drugs we have now really aren't doing anything, which is what we have.
It is exactly what we have. No, I mean, it's fascinating, but I think it's appropriate also to do what you just did, and that's highlight that right now where we are with this technology, it's not perfect. It really isn't. But I'm excited over what I think that we'll be able to uncover. And
it's so neat that right now, all that we can say and the data that's out there is right now, feed your microbiome what it wants. Treat it nice, which means polyphenols and fiber.
Yeah.
Feed it. Your microbiome will produce the things that you need, short-chain fatty acids, butyrate, things like that. And then try not to destroy the microbiome by eating a lot of emulsifiers. Most recently, xanthan gum. We should do a whole podcast on that. Xanthan gum, the binder was shown to disrupt the microbiome, and the microbiome can cleave it. Certain bacteria can cleave it so that you end up absorbing the sugar in xanthan gum when they say that it's calorie-free. So, yeah, we're learning more and more.
And for a long time, that's been viewed as completely safe.
Oh, yes, the whole time. In another article, it was discussing why do some people respond to chemotherapy and others don't, and the tumor keeps growing? Mm-hmm. They're doing a clinical trial right now where they're doing fecal microbial transplant plus chemo. Because as it turns out, if you have the right microbial diversity, chemotherapy works better.
Makes sense, though.
Totally.
If it's true that what happens in the gut is not only a gut-brain axis, but supplies the entire body, and we know that all of the cells work through signal, it would only make sense.
Yeah. So, quick recap. I'll let you recap the old mouse, young mouse story.
The old mouse, young mouse story. Old mice liked it when young mice were around, so they ate their poop and became young again.
Yes.
You like that?
Yeah, a couple of good pictures. That is a good children's book. Mine was way too wordy.
Yeah. We pretty much could have done the whole show in the last 2 minutes.
But exciting, fun. Hopefully this gets you talking. If you have any questions about this or ideas, we have access to literature. We can bring in experts on this. It's a really exciting topic that people are going to be, looking at a lot. And I'm super thrilled to see that right now the microbiome is one of the hottest things that is being researched.
Yeah, no, it's I think it's super exciting. And, it stinks that some people have to kind of pay the price for us to learn, but that would happen with literally any new innovation going forward, period.
Are you referring to you eating cow poop? Thank you for doing that.
Y'all are all so welcome. But, I mean, it's a good story.
It's a great story.
It's a good payoff.
We should.
What's that?
Sabine Hazen was asking for our poop. She wanted to analyze our poop. We should see if you've got like ruminant-style microbiota.
That makes so much more sense now. I do crave alfalfa and different things like that.
That makes sense.
It does. Well, that's going to do it for episode number 72?
72.
Also, be sure to like and share. And if you don't mind, write back to us and let us know what you think of the masterman, Paul, doing the intro and outro, especially if you're listening to the Spotify or Apple audio versions only. So what else do we need to add to that?
I think that's it. I think that's good. We're going to keep up. We've got lots of other topics we're going to cover. We're going to start bringing the guests back on here. We've just been super busy, setting up the whole set, getting people to do intros for us. And
yeah, well, thanks for everyone for all the feedback that we've received so far on the new studio. Like we said on the last 2 episodes, it took us longer than we wanted to get to this point, but we've done it. We've got a lot of cool things that are unfolding. We've got new announcements that we will be making as soon as they are available with subsequent shows, which I think will make it even more interactive than everyone just emailing and whatnot. It should be a lot of fun going forward.
Awesome. Appreciate all the feedback. Everyone, stay safe and feed your microbiome.
See y'all then.